Let me begin with you, John. Tell me sort of a primer on these neurological disorders and how we approach them.
Right. So I think following on from what Eric said, the study of neurological diseases is important for two related reasons. One is that they help us gain insight into how the normal brain is put together. Because in everyday life, our behavior seems so seamless, so easy. It's not until we have an injury to the brain that we suddenly see how, in fact, this seamless behavior is made up of component pieces. And so we can gain insight into those components and how they're actually organized in the brain in neurological disease. And then the second related area is that by studying neurological diseases, we can get insight into treatment. So I'd like to sort of give two examples of the kind of insights we can gain from studying neurological patients. And I'm going to use this brain as an example. A big debate raged in the 19th century between two camps. One camp that thought that brain function was divided up into localized components, and another camp that thought the brain did everything holistically, right? And interestingly, that debate goes on today, but and the reason for this debate was because it all depended what kind of disease you decided to study. So, for example, if you get a stroke in this motor strip here, you develop a paralysis in the limbs on the opposite side of the body. But otherwise, you're okay. You think okay, your language is okay, it's just the limb on the opposite side of the body that is affected. So that was a very strong case for highly localized function. But there are other kinds of lesion that cause a much more diffuse, broad set of abnormalities, which made it very difficult to believe that all of those could be actually controlled by one region. So, for example, you can get something called neglect, especially when you affect the right side of the brain, and you get the inferior part of what's called the parietal lobule. In these patients, they have great difficulty orienting, attending, and acting to stimuli in one half of visual space or in on one half of their body, in this particular case, the left side. So, for example, if you touch them after this lesion here on their left side, you ask them where you're touching them, they'll say, my right. When you walk into the room from the left, they'll go, hello, and turn their head to the right. Okay? So profound cognitive problems caused by a fairly focal lesion. So in other words, in some cases, the processing is very local, and you get a very focal effect, and that's why some people thought that it was all very localized. In another case, you have a focal lesion that has diffuse effects because of a knock-on effects to other regions, and you get a more global abnormality. And so you can see, by continuing to study patients with imaging techniques that allow us to see this architecture, we can actually learn fundamental principles about how the brain is put together. So Parkinson's patients have a part of the syndrome is bradykinesia. They move slowly. So a colleague of mine, Pietro Mazzoni, asked a question that one tends not to ask. Why do Parkinson's patients move more slowly? And the converse question is, why do we move at the speed that we do? So I'd like to do a little experiment just to show that. Is if each of you reaches for your glass of water, you'll find that all of us pretty much reach at the same speed. So on the one hand, you voluntarily decided to reach for the glass, but on the other hand, you unconsciously picked a speed which was very similar to all of ours. And what we think might be happening is that they have a different balance between how much effort is required to reach the glass and how worthwhile it is to reach the glass. And there, unconsciously, the balance is moved towards it being too effortful to move fast, to get it in the same time that we do.